Hello students, we're almost there. Welcome to Module 4, in which you're going to be learning about ratios and proportions. What is a ratio? A ratio is a comparison of two quantities that have the same units. This comparison can be written in three different ways: as a fraction, as two numbers separated by a semicolon or a column, and as two numbers separated by the word two. Let's see some examples. As you can see, the ratio can be done as a picture or pictographic. For example, look at the picture of the teacher with the children. It can also be used as words: teacher, semicolon, children, or teacher to children. Or 1 to 5. We always write 1 to 5 ratio. We also can see that yellow stars to purple stars has a semicolon in between them. You can do that with words, or you can do that with a number. If we look at the ratio between the Coke cans and the orange juice, we can see that there are 3 Coke cans versus 4 orange juice. So the ratio is 3 to 4. Other ratios that you can see is, for example, 5 to 9, or 5 semicolon 9, and then boys to girls. Boys to girls is a word ratio. It helps you to organize your ratio. In the following picture, we have what is called the golden ratio. The golden ratio has existed for more than 5,000 years. The golden ratio comes out to 1.618, and it is present in nature. Our body dimensions follow the golden ratio, and many things in nature, paintings, and art. We don't exactly know how farther past 5,000 years the golden ratio has been with us, or why it is inherently present in everything. The golden ratio is used for market movements such as stock, bonds, and Wall Street market, weather forecasting, of course mathematics, physics, astronomy, and space mechanics. Photographers use the golden ratio, and also, as you can see, it has been part of architecture since Babylonian and Egyptian times. Now let's talk about the simplest form of a ratio. Writing the simplest form of a ratio means writing it so that the two numbers cannot have common factor other than 1. Quantities such as 3 feet, 12 cents, and 9 cars are a number quantity. Sometimes we call these units. The number itself is called value, and feet, cents, or cars in this case are the units. Another example of units are shirts, dollars, trees, and miles. These problems are important to learn because are the foundation of many more courses. You're going to be doing ratios and proportions in the healthcare field when you're calculating dosage of medication. Ratios and rates and proportions are normally seen in physics courses when we're trying to calculate how fast a car moves or how far away something versus another quantity. For example, the ratio of the lengths of two boards, one is 8 feet long and the other is 10 feet long, can be written as 8 feet over 10 feet, or 8 over 10. If we simplify the fraction, we will get 4 over 5. As you can see, the ratio can be written as a fraction 4 fifths, 4 semicolon 5, or 4 to 5. Now, a lot of people get confused between what a ratio is and a rate. since they pretty much sound the same, and they're sort of related in some problems. A rate is a comparison of two quantities, just like ratio, but in this case, they have different units. A rate is written as a fraction. For example, a distance runner ran 26 miles in 4 hours. The distance to time rate in this case is written 26 miles over 4 hours equals 13 miles on 2 hours. If you really wanted to simplify this and you were not looking for whole numbers, you could say 6.5 miles in 1 hour. Notice that the above rate is written in the simplest form. We write in the simplest form, and this means that we cannot reduce the fraction any longer. These are some examples on how to use ratios and rate. Rate is used in healthcare when they're doing EKGs on a patient. When we're saying that 75 beats per minute or heartbeats per minute, you can see that they're putting the number of heartbeats on the top or numerator of a fraction, and then the minutes or time variable goes on the bottom. To get the unit rate, you will divide it. In this case, 75 heartbeats per minute. Rates are used for everything. As you can see, this is a poster that was produced by giving information to patients about the cause of chronic disease. You can see they say $3 of every 4, or 7 out of 10 deaths, or 1 in 3 children. All of those are examples of rates ratios. Finding the unit rate is easy, and you probably have experienced this when you go to the supermarket. If you go to the supermarket and you're trying to buy groceries, look at the sticker with the price. In the sticker with the price, there's always two prices. One is the price that you're gonna pay when you buy the item, but in small numbers next to it, you will see something called the unit rate. The unit rate is a number that you should be looking before you purchase anything, as this will tell you the real true value of an item. In this example, Ralph Lowe of Germany flipped a pancake 460 times in 120 seconds to set the world record. They're asking us to find the unit rate. We should round our answer to the nearest 100. The first thing we need to do is we need to write proportion to find an equivalent ratio with the second quantity of 1. Then you're going to cross multiply as you always do in proportions. 120 times x equals 1 times 416. If you left x by itself, you will find out that x is 3.47, or the unit rate. In this case, he did 3.47 flips per second. Solving proportions is easy. Pretty much what you're doing is you're solving for a one variable equation in which you're trying to find the letter or the unknown variable, the one that we don't know about. As in the case of 3/9 equals 5 over m, we see that we don't know what m is. The m is the unknown. Look at on your left hand side and you'll see how they multiply or cross multiply the proportion. Using cross products, in one side of the equation we get 3m, and in the other one we get 5 times 9. 3m equals 45. And then what we do on one side of the equation, we gotta do in the other one. In order for us to leave the n alone, Since the 3m or the 3 is multiplying, we need to divide both sides by 3. This will give us that m equals 15. You can practice more of these on your own time, but I wanted to give you 2 examples so you saw how to solve a proportion. This is an example of unit rate. Normally we read unit rates just like it sounds. For example, $3.25 in 1 pound or per pound. Another unit rate, we can be calculating how fast a rocket goes. 300 feet in 8 seconds will be 37.5 feet per second. We can also use rates in math problems, such as this one. You probably have seen these problems in physics and calculus application problems. The car was driven with 345 miles on 16 gallons of gasoline. So how many miles did the car travel on 1 gallon? Let's find out in the next video.